Let's solve these problems. Evaluate the following integral. So let's start with 1. The integral of sine to the fourth x cosine x dx. So we can apply u-substitution first. So we can let u be equal to sine x. Getting the derivative of both sides, derivative of u du. Derivative of sine x, that's cosine x dx. So therefore, we have created this term, cosine x dx, which is equivalent to du. If we substitute, we will have the integral of, so this sine x is just equal to u, then raised to the fourth power, so we have u to the fourth, and then this cosine x dx, it's equal to du. To evaluate this integral, we can apply the power rule. That is, if we have the integral of u to the n du, it is equal to u to the n plus 1 over n plus 1 plus c, provided that n is not equal to negative 1. So therefore, to evaluate this, the integral of u to the fourth du, it's equal to u raised to 4 plus 1 over 4 plus 1 plus c, or u to the 4 plus 1, that's 5, over 4 plus 1, which is also 5 plus c. So, transform back the u in terms of the original variable, which is sine x. So, we will have 1 over 5 u, which is sine x, raised to the 5th power plus c. For number 2, we have the integral of ln x over x dx. So, this time, I can let u be equal to ln x, because when we get the derivative of ln x, we will get the term dx over x. So we will have derivative of u, that's du, and derivative of ln x, that's 1 over x dx. So substituting, we will have the integral of ln x, that's equal to u, and then this dx over x, that's equal to du. So again, we can apply the power rule. So the integral of u du is, so this u, by the way, has invisible exponent of 1. So by power rule, its integral is equal to u raised to 1 plus 1 over 1 plus 1 plus c, or that will be u squared over 2 plus c. And don't forget to transform back the u in terms of x. So u is ln x, so we'll have ln x raised to the second power over 2 plus c. For number 3, we have the integral of e raised to x over 1 plus e raised to x quantity squared dx. Again, let's use u-substitution. So we can let u be equal to 1 plus e raised to x. Get the derivative of both sides. Derivative of u, it's du. Derivative of 1 plus e raised to x. So derivative of 1 is 0. Plus derivative of e raised to x, same, e raised to x. So we have 0 plus e raised to x, or simply e raised to x, then don't forget the dx. So therefore, we have created this term e raised to x dx, which is equal to du. Substituting the value, we have the integral of this e raised to x dx, that's now equal to du. Then over 1 plus e raised to x, that's equal to u, then raised to the second power. So before we can apply the power rule here, let's try to transform 1 over u squared in terms of negative exponent. So that's equal to the integral of u to the negative 2 du. And therefore, the integral of u to the negative 2 du is u to the negative 2 plus 1 over negative 2 plus 1 plus c. Or we will have u to the negative 1 over negative 1 plus c. Transforming into positive exponent, it's the same as negative 1 over u plus c. And don't forget, let's transform back the u in terms of x, which is 1 plus e raised to x. So the final answer is negative 1 over 1 plus e raised to x plus c. For number 4, we have the integral of the square root of arc sine of x over 1 minus x squared dx. So I can distribute first on the numerator and denominator the square root. So it's the same as the square root of arc sine of x over the square root of 1 minus x squared dx. So let's use u-substitution. So let u be equal to arc sine of x. Getting the derivative of both sides, derivative of u, it's du. Derivative of arc sine of x, that will be 1 over the square root of 1 minus x squared dx. So therefore, we have created this term, 1 over square root of 1 minus x squared dx, equal now to du. Then if we substitute, we will have the integral So we have the square root of arc sine of x, which is u. And then this dx over the square root of 1 minus x squared is now equal to du. So we will have square root of u du. We can evaluate this using power rule, but let's transform first this square root of u as fractional exponent. So we have integral of square root of u is the same as u to the 1/2 du. By power rule, the integral will be u to the 1/2 plus 1 over 1/2 plus 1 plus c. Simplifying, we have u to the 1/2 plus 1, that's 3/2, over 1/2 plus 1, also 3/2. Then, just simplify the complex fraction, get the reciprocal of 3/2, that will be 2/3, times u to the 3/2 plus c. Finally, let's transform back the u in terms of arc sine of x. So, the final answer is 2/3 u, which is arc sine of x raised to 3/2 plus c. Okay, so now it's your turn. So try to evaluate this integral and just comment your answers.